Hi everyone, this is the Python K-means cluster tutorial for Python. Yeah. The first things first, you want to download Anaconda Navigator. Launch Jupyter Notebook. That, and here's the tutorial. Again, all the files are attached to this video, so be sure to follow along by opening the file. So with any Python project, you want to install packages, libraries first. These are pretty self-explanatory. You don't have to understand them. Just use the functions based on. And we're going to talk about errors later. Doesn't matter right now. So from these libraries, you want to import all of them, just like this, as variables, specific functions from scikit-learn. Again, you kind of just copy paste this section. There isn't much understanding. Now extracting the data itself. Let's actually run the code again. So we're using the life expectancy CSV file, just here. Again, it's attached to this video. We're then gathering data, generating text, delimiter, makes sense, comma, spliced value. That's what CSV stands for. And then using columns 3 to 22. And that's because we have data on columns 3, life expectancy, all the way to 22. And we're skipping the header. Same thing for the label names. We're actually using column 0, makes sense, because we're just looking for the country there. Self-explanatory. Then we're clicking the data. So we're actually transferring this NumPy matrix, that's what it is, NumPy matrix, into a data frame. Data frames are basically matrices themselves, 2D matrix, except that it has specific analysis tools from pandas that we can use. And with the missing data, we're filling in zeros. That's what that means. Then we're transforming that data matrix back into a NumPy matrix. And that again. And then we can take a look at the matrix. Take a look at the labels. Afghanistan. Makes sense. Actually, first do this. Oh, sorry. And now let's talk about pipelining. So pipelining is basically transforming the data, dimensions, or using it for clusters, pretty much. That's what pipelining is, transforming. First, we need to encode the labels into numbers. It cannot read strings. Then we transform these labels. So specifically with this, we actually have to make this function a variable like this. And then we can run it. And it makes sense, 0, 0, 0, because based on the label name here, run this again, Afghanistan. Makes sense. Because if we look at the classes, we're not taking duplicates. So these are all the classes. And these are going to be the amount of clusters we have. And we're going to use this variable specifically later. 193 clusters, yes, believe it or not. Now for the actual pipeline. Run this. It takes a while for it to run, so let's run it quickly. So for the first pipeline, I'm going to create the preparation pipeline, basically the pre-processed pipeline. It is taking our data and scaling it to a normal distribution. Normal distribution is basically making values close to the mean, close to the average. So you have this bell curve, and all the values are close to that bell curve. That's what that means. And dimensions of the matrix are going to be smaller. So this does it. PCA stands for Principal Component Analysis. Yeah. And again, it just reduces dimensions. Random state is the random generator it uses. It's a specific value, you can call it the seed. So it's not really a random. There's values that we're choosing. And I'll talk about the components later. Now we have the cluster pipeline. So of course, this is the k-means cluster. Total clusters here. The same amount of clusters we'll have. Then we'll have initialization type k-means. K-means plus means distance from the centroid, the center of the cluster. Cluster up center, cluster up center. Distances. That's what the initialization is doing. And initialization is just basically execution. So we have 50 executions. Then for each iteration, each initialization, we have 500 iterations. And again, the same seed, random number generator. And then based on these two pipelines, cluster and preparation, we make a huge pipeline. And then we fit our data. It looks like this. This is basically the tree. This preparation and this k-means to one big pipeline. Now on to the last section, plotting. Most fun section, right? So we're gonna take that preparation, which is the most important one because it has our data, and make it a data frame to use for Panda analysis tools. Again, Pandas is the library that has the tools we want. It's PD. Using preparation again, for data, and using those components. Remember this? Dimension and components. Basically, two random components that we're going to use to graph. And then we take this data frame, the predicted. This is a label based on the cluster k-mean over here. And we're actually going to use that as like a color for our legend of graphing. Same with the real label here. This is just the label. So instead of numbers like this, well, it'll be back into label names. Basically, that's what the inverse transform does. You don't really have to understand the specific coding. Just copy and paste. But you really do just have to understand. If you change something, change a certain parameter like this, what does that actually mean? But again, the format doesn't matter. So back to the project itself. The PLT style. PLT is matplotlib pilot. That's what PLT is. You're using the style 538. There's actually plenty of styles. This is 538 here. But we can also use ggplot. And the figure size is pretty self-explanatory. Scatter, we're using Seaborn package. Doesn't really matter what that means. But this has the best options for plotting XY, those components. S, this is actually a number of initializations. Again, using the data here. Predicted, again, using this. These are for our labels. Hue and style, labels. And set 3. Okay. So yeah, let's run this. And the legend is pretty self-explanatory. It has the predicted and real labels we want. And this is our graph. This BB box anchor here puts our legend to the side. And the location best just puts it wherever it looks best. These specific parameters means 1, 1. X, Y coordinates, that means top right, pretty much. Let's change some parameters here. Make this ggplot. Well, we get 10 by 10. And we'll use palette 2. I think palette 1 looks better. And yep, looks much better. Remember that we had 193 clusters, so that's why we have a huge legend. So a big key takeaway this video is that If you have a bunch of labels that have the same value, like this duplicates, then go for a cluster algorithm. K-means. Yeah, that's it. Thank you for watching and good luck on your project. Bye.
Hi everyone, this is just a simple update to the original video. As you can see, the document itself is much cleaner, looks better, and I added additional coding, and I'll explain what that does. So you'll see a lot of optional headers, that's what the op stands for. So this is for if you don't have any labels in your data set. So I mentioned briefly that if you have multiple labels of the same value in your data set, you should use a clustering algorithm, in this case K-means. However, if you don't, that's okay. If you want to install the lead package, and from that package, you want the function be located. Import that. And you can comment out all these labels that I made the comment for. Like that. So this is a multi-line comment, use quotations. You can use double quotes. Just use hashtags for single line comments like this. Single line code, in this case. Double quotes, doesn't matter. And hashtag here. So this is actually going to be commented originally. We'll just get rid of them. Again, I'm just adding and removing them for the point of demonstration, pretty much. So there isn't too much need to demonstrate what this code does. Let's just run it. Basically what this does is K-means you'll use this parameter here. That's what the brackets mean. It's just like a parameter of random values. And you use it in this for loop here. And you want to use the number of clusters as I, because we're going to loop. We're going to loop to find the number of sum-squared errors, basically the error values for the total amount of clusters. And basically whichever is the lowest in this loop, that's what this pretty much does. Whatever has the lowest squared error, the lowest error value is going to be the lowest point, the smallest value, and that's going to be the elbow. That's what that means. It's kind of weird, and you don't really have to understand it, just plug and play. And the value of the cluster with the lowest amount of error is 7. 7 clusters. And then we put it in the pipeline. And again, this comment would not be commented out, so comment this with a hashtag. Same with this hashtag. Let's take a look at what it looks like now. Wow, 7 clusters. So originally it was 193 clusters, so this looks much cleaner. But again, if your data set has multiple values, it's better to go stick with the multiple values because that's more accurate. So yeah, hope you understand, and thank you.